Welcome everyone to today's multimedia presentation on Coding Quest as rotation stations. We're going to be focusing on building a compassionate community of computational thinkers and learners. I'm very excited to share all the wonderful learning today, and my name is Naomi Harm as your guest presenter. I am a CS for All Teachers Community Ambassador. If you would like full access to this shared collaborative slide deck, please feel free to tap into the shortened bit.ly link as you can see on your screen. Now, we're going to provide for you a creative, inclusive opening because we want to gather some background information on where you are with your understanding on computational thinking. At this time, you could pause this particular multimedia presentation and go to that link, as you can see, which is the bit.ly link at CS for All Teachers Jamboard. But we would like to know what you're thinking and what you have prepared as learning strategies and ideas to get teachers and students thinking differently when it comes to computational thinking. So many of you already know that computational thinking is really a problem-solving process. It's the broad problem-solving technique, and it includes at least these four elements of decomposition, pattern recognition, abstraction, and algorithms. And when we afford our students and teachers an opportunity to take a complex subject matter and break it down into smaller, distinct parts, that's when they can look for those really verified similarities. They can identify relevant information, but also provide opportunities to simplify the learning, but make greater learning gains to see how the bigger picture all fits together. And then they can create a plan for an ultimate solution. So some examples that we can see all around us would be inclusive of making a recipe, instructions for creating, making, putting something together as a step-by-step process. Even like a building block sets when we have our Lego sets that we have to do in order to create that ultimate end product. Playing in sports, because that's very computational when it comes to step-by-steps in order to follow that process. How about online map reading in your directions that you'll do? So because of this, I'd like to know what types of areas or teaching strategies or ideas do you provide teachers and students? So tap into this link and then go to the Jamboard of the frame that is representative of the area that you teach. So I have them broken down by elementary, middle school, high school, and then a specialty area. Love to see what you're thinking. Would love to see the ideas of how you are creating a great, just empowering learning environment for your students to understand the power of computational thinking and the association with algorithms. Now, when I kick off a lot of my trainings for teachers or when I'm co-teaching with teachers with students, I like to ground our learning always in a wonderful literacy of a story. Now, Sarabella's Thinking Cap is one of those I love to read aloud because you can even just close your eyes as the story is being read and you can imagine everything that's taking place in your big, beautiful brain about all that you'd like to daydream about of you being a creator, a maker, and a computational thinker. So this is a wonderful book to tap into if you haven't yet. But this is how I even introduce to my teachers that I work with because it really grounds their thinking to prepare for the next learning opportunity. Then from there, I usually like to introduce a design thinking challenge. So from that literacy book, I always make a connection. And Sarabella had this big, beautiful hat on, which also encapsulated all of her dreams of making and her computational thinking of how she solved problems. So I introduced this to teachers and students that we do a 6-hat thinking challenge. And it uses recycled K-cup pods that are made for making in your coffee maker if you use that type of item. I first introduced to our students to get them thinking differently of how they learn best and to discover why they learn best. This is a 6-hat thinking Jamboard activity as well that you can use, that you can take and drag and drop the dot to the area to represent how you learn best. This also is inclusive to honor and respect diversity in the classroom. Yet it's a great way that I could put students or teachers in job-alike groups because of how they think and how they learn. Yet the learning really gets better than chocolate when you can diversify the group and you can have a colored hat in each group to be represented to really have divergent thinking taking place. So again, this is a great way to get to know your students and your teachers that you're working with, but to also know the strengths that each can contribute to these learning groups, but also to understand and to listen to understand the differences of reading and how people, I should say, how you read the room, and then how people also understand how they can listen to understand the viewpoints of others. Now, this design challenge that I have set up basically has no real limitations of it. But what I love about it is that you provide your students empty K-cup pod, or they can bring them in from their home if their parents have them or guardians. And then from there, just have some maker craft supplies available. Anything that you have kind of left over in your cupboards, students can bring in items as well. But sometimes I bring in ribbons, I bring in pipe cleaners, glue sticks, the googly eyes. And why the googly eyes? Because it gives it an eye-bombing effect to make it more humanistic. But colors matter, right? Because we just learned from the 6-hat thinking study that we just looked at that color should resonate and come through to represent that person's unique personality. There's no design limits. They can do anything they want to design this K-cup. Yet at the same time, too, I usually have students and teachers be at collaboration tables that they can inspire others with their ideas. Upon that time, when they're done creating and making, at about 15 to 20 minutes later, I have students take a picture of their K-cup and then they add it to a collaborative shared Google slide deck or a Microsoft PowerPoint. And then they share their why of their unique individual you. So through this template, this is the Google slide that I will have for you, that you can even practice with this before you give it to your students, but you can make your own copy. And it's set up as a template so the kids can add the area of their picture and then they can explain their why. I also have been doing this for a few years, so I've got some great teacher examples of teachers and students from all over the globe of how they have designed and created their particular K-cup, which represents their 6-hat of thinking. Now, as we continue with this, after we complete that activity, something that I always notice is that most teachers and students have great success with that last activity, but there could be some that have a few frustrations that may come into play. So I follow up with this book as a calming technique, and it's called After the Fall, Read Aloud. Many of you may already know the story of Humpty Dumpty, but did you know that there was a follow-up book to Humpty Dumpty? It's called After the Fall. And this is what happens of everything that happened after the fall from Humpty Dumpty, as he persevered and he was dedicated and he wanted to make sure that he got back up on top of that wall and what he could do to see over that wall and what he found. And then I won't go into the story about what happens next, but this is a great way to help students understand that failing and struggling and persevering is part of the natural struggle at times that we may have. Yet, when we follow through to continue to persevere, great things can come about of what we've created or what we've done or what we've discovered, and make that project or that product even 10 times better than we could have ever imagined. So some items that I'd like to share with you that after I do a literacy foundation grounding technique, getting everybody involved, we do a quick hands-on activity for 15 to 20 minutes, and we add that calming technique. We transition into creating and making coding quest rotation stations. I usually divide up the students or teachers in transformative trios, so there's at least 3 people in a group. So there's lots of dialogue, lots of conversation, and they can help each other. Yet at the same time, these coding quests encapsulate high-end technology, unplugged activities with no tech at all, tech enhanced activities, and then that literacy based again as well, to really focus on some great structured reading and writing to reflect on the learning. And it captures the learning of the students and teachers involved and how it relates to their world. So station number one that we can have set up in the room. I love using Dash and Dot from Make Wonder. And Wonder Workshop is also the creators of this, but their website is makewonder.com. And what I like about the rotation stations with this, it's applied and physical coding and robotics for the students. And Dash and Dot are such friendly little robots, and they're so interactive and they're so colorful. The kids in general are just drawn to them, and so are the teachers. But what I love about the applications that is provided and with the app itself, it's an easy drag and drop blocked based coding. And the kids figure it out right away. But what's so nice about this, it fits so nicely into your thematic units of study because you can incorporate anything from science to math to social studies and to reading and writing. And I also complement by, like I said before, we do the applied physical coding and robotics as one station, but we make sure that the next station that we have some unplugged activities. So as an example of this, to put it into context to grow that literacy skill set, perhaps we're going to be creating a word search. And a lot of times we do a word search with a paper and pencil. So instead, what I have my students do is that we create a word search basically on the floor. And these are letters that we will put into a word search. We just use masking tape. We put letters in each of the center of those particular spaces. Then from there, we put cups around this little game set area of a 1, 2, and 3. So the students then in return can spell at least a 3-letter word based on which grade level that they're in. And then when they spell that 3-letter word, then they have to code the path. So a lot of times they use a paper and pencil technique. And then what they will do is they will actually code the path of doing the rights, the lefts, the forward, or the backwards. So they need to know what they're doing for their strategy. So they're really putting in a game design for themselves, but to sketch note it out. Then they have to code it on the iPad and to synchronize with what we'll do here with Dash, and then to code that path. When they've spelled that letter successfully, then from that area, they can take a shot because they will put on the launcher on the back of Dash, and then they will launch the ball either into cup 1, 3, or 2, and that's how they earn their points, besides earning the correct letter score as well. So this is just a way that we've put it together to make it a little bit more gamified, but the students can help one another to be successful with actually creating 3 or 4-letter words. Some other things that we've done with our older students as well, when we're really working with slope and other opportunities to really incorporate some math skill sets, and when we're working with angles and things like that, that we've had kids create their own types of ramps out of cardboard. And then they will take Dash and they'll have to speed him up or her up and then go onto the ramp and then launch the ball into the basket. And we talk about a maximum slope of 20% of what they need to do. And it needs to support enough weight to get Dash up the ramp a little bit. So this challenge in general, the kids really love as well. So it really puts things into perspective of those great math skills. And where do we see slope and perspective every day in our lives? So we have great conversations around that. Some other rotation stations within that area of that station 1. So there can be a designer challenge to make your own ramp. We can have Dash and Dot that they're creating the word search. But then I love these activities. This is called hands-on coding. And this has no technology involved with the exception of the 3D printed blocks. I have stories that are used for this purpose that kids will use the blocks to sequence their story. So it could be that a book they just read, it could have been maybe the literacy book that I just read at the beginning of this presentation, but they actually code the story and create a new ending. So for them, they can now see how coding and computational thinking with a story is actually a beautiful algorithm. So all of this comes into play that the kids absolutely love it. A few other things that I do to be successful in the groups, especially when I'm working with students, is we make sure that students actually have a job task card, and they wear this almost as an honorary badge. Why it's important that students have roles in their particular roles that when they're in their groups is because these particular students need to make sure that they feel that there's a value add, they have something to contribute, and everybody contributes to be successful of completing that task. So these are very specific jobs. As you can see, these are STEM role cards. So there's going to be a challenge captain, a materials master, rapid reporter, chief architect, and testing coordinator. Everybody has something physically that they have to do. And if somebody falls back and doesn't follow through, that team or that group will actually fail. So these are just examples of what could be set up, but you may want to come up with your own, especially when you're using applied and physical coding and robotics with your students. Station number 2 comes into play that we're going to look at doing some paper crafts and some prototyping. What I like about this is you can use paper fortune tellers, and this particular one is called the shark cootie catcher is what they call it, but we call it paper fortune tellers. And what I like about this is that this is a paper craft that you can make into a shark, or there's other animals that you can create too. And what we normally have done when I was a student is, you come up with a rhyming technique or you sing a little song and then you land on something and then you'd open up basically the mouth of that shark and the number that you'd land on. So if the inside they're labeled 1, 2, 3, and 4, you'd pull back that number 4 if that's the number I drew. And underneath number 4 is a design thinking challenge that can be an engineering challenge. So this is what it can look like. So that shark as that fortune teller, as you'll see here, is that there's a template that I have for you. There's also a video of how you can create it. But what I like about it is giving the students the opportunity to number it or put a code on each particular quadrant, yet having the students design the coding or the engineering challenge, and then they work with a teammate to solve the problem from there. It gets kids really, really active in the learning. It's a great activity to extend to the home environment as well, too, because many of your parents will remember using fortune tellers as well. Some other things that I like to follow up anytime that we're doing these stations is I want to capture the thinking and the learning process with these kiddos. So what I do is I build in a few different types of protocols. This one's called Collection of Ideas and Clarifying Questions Protocol. It's designed in a Google document, and being designed in the Google document will allow for you that it can be highly collaborative. You can also take these and print them out and cut them apart, almost like an exit slip in a way too. But knowing that everybody has a voice in their learning, because sometimes we know some of our kids will overspeak over other students. So we need to make sure that everybody has a voice, they can share their ingenious ideas, and they can write by recording their information of their unique thoughts and ideas. So it's actually physically documented. And this is a great way too that you can use that if you want students to actively listen to others, they actually write the speaker name down so they're actively listening. They can identify the main idea that took place and then a clarifying question that they may want to pose to this individual to extend the learning for everyone in the group. As we continue on to rotation station number 3, I absolutely love working with coding with real life skills, especially when it comes to cooking and your recipes that we do. A lot of times when I work with my students and even teachers, they never have made that association that computational thinking is a beautiful complement to our cooking recipes, which is an actual beautiful algorithm. I have created an Instructables magical coding recipe that you can create to create your own cooking show. What I like about this too, it really showcases different ways and strategies of how to actually put items into a sequence to be successful to solve basically a problem or the final product. And just like within cooking, if something doesn't get added correctly, we add too much of one thing, not enough of another, or we delete something, the whole recipe can fail. So it's just a really great analogy, putting it into context for our kids. What I really like also is this supportive video that goes along with how these girls that are involved in their Girl Scout troop and how they put the analogy together of how cooking works together. And this is a great way to make that symbolization for your students, especially at that upper elementary, middle school level as well. And then having your students bring in one of their favorite recipes that they have from a family member or a guardian, and then to recreate those steps. And what happens when we forget a step? And what's so interesting is because a lot of times when we do the technical writing, we may forget a step because we just assume it's understood or interpreted. Or in all actuality, when we have to do code, we have to be very purposeful. We have to be very in tune to how that code is written, because even just with one mark that is missing or an extra character that's inserted, it will actually make that code fail. The same way for a recipe.
We are Junior Girl Scouts, and we love to make movies to help other people understand things. We made an educational video about coding. It'll be shown to 16,000 students in our school district. First, we had to do some research on coding. Then, we wrote a script. Then, we had to record the scenes, which sometimes took a lot of takes. And then we had to edit it and put it all together. We used our Girl Scout teamwork skills to put together this whole project. Now sit back, relax, and enjoy the movie. What is a computer code? A code is a set of instructions that tells the computer what to do. The code is called an algorithm. An algorithm is a set of step-by-step instructions that performs a task. People write the code. The code powers the computer, and the computer powers many objects like phones, watches, TVs, and cars. Most of us think writing an algorithm is something we only write for a computer. But we use algorithms every day, like when we use a recipe to cook something. When you write an algorithm, you have to break it down to small, specific steps. Programs need to be really specific. They have to have step-by-step instructions and algorithm. Let's make cookies! Coding is like writing each step in a recipe. So I'm going to write a cookie recipe. And the computer, or the cooks in this case, will follow my instructions. But if it doesn't turn out the way we want, we'll have to look at each step and fix the problem. So I'll read the directions, or algorithm, and you do exactly what I say. Pour a cup of sugar and put it in the bowl. Wait, stop! I guess I need to be more specific. She put the whole cup into the bowl, so I need to change that step. This is called debugging. Measure 1 cup of sugar and pour only the sugar into the bowl. Next, measure 1/2 teaspoon of salt and pour only salt into the bowl. Great! Next, put in 1 egg. Uh-oh. You were supposed to crack the egg first, but your instructions didn't tell me to do that. Again, when you write directions in coding, you have to be very specific. So now you need to debug the program again. Now, crack the egg in a separate bowl and pour only the egg without the shell in it. There are different types of coding. Here's one example of a simple programming language used in Angry Birds on code.org. We're trying to get the red bird to capture the green pig. Move forward. Turn right. Move forward. Run. That gives you an idea about how specific coding needs to be. It's up to the computer programmer to give the computer a list of instructions. Think of a computer like a well-trained dog. It listens to your commands and does what you tell it to do. Okay, friends, let's finish our cookies. Okay, bye now.
So as you can see from that video, those girls were so excited to make the connection with their real life cooking skills, but it was so extremely relevant because they had to decode, debug, and even take some steps back and had to repurposely go through the steps to making sure that everybody was on the same page. So that's a great video to showcase to your students, to making it extremely purposeful. Now, if you're looking for some other ideas of relating it to cooking, this is a recipe slide deck to use to share with your learning. And this is a great way that you can actually have students work in those transformative trios. As I mentioned earlier, they can create their own recipes and helping them debug their code based on the interpretation of the recipe that they bring in from their students. I think this would just be a wonderful and fun-filled activity, yet to celebrate the diversity of the wonderful cultural aspect of all the different types of recipes that will be brought into your classroom. Now, as we continue on with rotation station number 4, these are some ways to do lots of activities that are unplugged. That means not having any technology at all. A lot of times I use these activities that we just find recycled materials that are extra, that are perhaps in the classroom, or parents or grandparents or others have donated to the school that we can use to create and make. It also has a very, very wonderful foundation of an engineering and tinkering and making feel to it. And the students really like to be building and creating and making with this. So here are some of the stations that I've set up in the past that I could set up 5 or 6 of these actually STEM mystery bags. But in the mystery bags, I usually have just a little note card or an index card with the title of the activity and what they need to do. Sometimes on the index card, I'll also put a QR code. And if they scan that QR code, I'll have my voice embedded. And so that will help them know what they need to be doing at that particular rotation station of that activity so they can hear kind of the directions. But basically, these are self-directed activities for kids to work in groups. And I, as the facilitator, can now rotate between the students. And we try to make it a point that we have kids that will rotate between this about every 20 minutes or every 30 minutes. But they'll have someone that will be in charge that will be opening the bags. Someone will organize as they explore the contents. We'll have somebody that will be the avid reader that will read the directions or listen to the QR code that's been embedded with the voice audio. And then we'll have that team to design, create, and test. And they're going to create a new prototype to improve the overall process of what they're creating. And then they'll respond to a task through a protocol as a learning prompt. And then they will be responsible to place all of the contents back into the bag again, and they'll leave that bag at their center they were at, and then I just rotate the kids to the next area so everything stays there. It's a really good habit, too, for kids to be responsible. I mean, to take things out, to set them out, to organize, but how to put them all back together, organized in the bag for the next team. I mean, that is just very much a responsible learner technique. Some other things that we use also is the design protocol. When kids are learning and thinking, it's important that they're documenting their learning because they can quickly forget if you wait to the end of the engineering activity or the coding experience. So always have a piece of paper and pencil and have it as set up as a graphic organizer because it's breaking that content down that can be complex for a lot of our students into smaller, snackable, bite-sized chunks of information. And then it also helps them too because if something happens in that particular group and they're struggling to find why didn't this work, they can go back through their steps and basically they debug their steps to find out, say, oh, we forgot a step here, or oh my goodness, we forgot to add this piece of material to make it work to do this. So it's all about that critical thinking, perseverance, and helping your students understand that whole process that's involved. Now, as we continue on with rotation station number 5, this is another area that we need to provide more girls, especially, and boys, mentoring superstar access so they can identify and relate to an individual that looks like them, resembles them, and has experiences that are actually very similar to their own lives. One of my favorite mentoring sites is called Sci Girls, and this is coming from PBS from Minnesota. They've done such a nice job that they have curated all of these wonderful women from around the world of their focus on their STEM jobs and computer science jobs. They talk about what they were interested in when they were little, who supported them and mentored them to help them make their dream come true. And how did they struggle along the way? What frustrated them, but how did they persevere to overcome that? And what did they create and contribute to a greater world of good? So a lot of times what I will do with our girl students, I will give them a protocol that goes along with this. And I may show one or two, and it really excites them. Then I let them choose one that they'd really like to watch. And then from that, what I'll do is I'll use this activity, which is called a Give One, Receive One EduProtocol. The girls will watch a Girl Superstar segment, and they're not going to do any writing yet. I want them to actively really listen and watch that video. Then we're going to partner up with a whole class, or it can be a group table discussion. It's really based on your size of your group. We're still not writing yet because now it's our time to actively listen to the learning and their peer understandings and new ideas and perspectives that the others have watched from watching those videos, what they found insightful, what questions they still may have, what learning connections of prior knowledge that they may be willing to share. Then I have students that you can have this set up through a Google slide deck or a Microsoft PowerPoint. And I have two students partner up as a dynamic duo. They claim their slides. So one student puts their name on one side, the other student puts their student partner name on the other. And that's when they really document what they were so fascinated, even more so now, about that Girl Superstar segment and how it relates to them personally. So they reflect on their learning. Then I partner them up through a flip grid that they can voice and share their learning even further. So their ideas are really documented here. So it documents their learning process, but then they get to celebrate the learning by sharing with someone else through that video portal. If you would like this to have this template, I do have it here that you can tap into. Now, rotation station number 6, this is one of my favorite online tools. It's coming from the Convergence Lab out of San Francisco, California. And this is called Design Your Passion to Purpose CS or STEM Challenge. What I like about this particular online website is that it really focuses on what you're truly passionate about. And it can be a personal interest or it can be a professional interest, yet also it impacts the bigger picture of our world. What do you want to do to contribute to a greater world of good? What do you want to do to help mentor someone else? What do you want to help to do to focus on that social cause? So this will take you through about 12 to 15 questions. And when you're done with the 12 to 15 questions, it collates all that information and then it creates a beautiful learning outcome as a design thinking challenge. And it really is based on your purpose, your why, your strengths, and your understandings of what you're very passionate about. Now, you can always go back to this and change around any of your answers to those question sets, because if something just didn't quite turn out, it's okay to go back and try again. But this has been a really unique way to get more kids to own their learning and feeling that they have that value add, that their passion is really coming through and they have an opportunity to persevere and to really create something that really shows what they know that they're very interested in. So I hope that you'll tap into this particular one. After I give them that passion to purpose strategy of doing that, then I challenge them to put their passion to purpose into practice. And what they'll do is we use this as a STEM challenge with data results. And what they will do is they're now going to create an engineering design challenge to use in the classroom tomorrow. So it really inspires them for something that they just now created. How can they take it and go one extra level and create that next design challenge with their group of students as well? I always follow up, as I mentioned before, that we do a lot of reflections. This one's called a 3-2-1 Flip Your Thinking and Why protocol. Again, it's a Google Doc that I have set up. But this is something to really add closure to these types of activities, to add the calming to the end of the activity, but to really celebrate the learning. So after that lesson or activity, you can use this with students can add 3 pondering questions they may still have about the material, the learning experience, or maybe they got stuck somewhere. What was it that they had to do to persevere to get through it? Then they will record two things that they found interesting, and then they share their why. And then one thing that they do is the student will record one mind-blowing learning moment that the student has learned from the lesson or from another student that they found so fascinating. So I hope that you can use this protocol. It's a great way to capture the creative thinking of your student. It documents authentic learning, and it really meets the personalized learning need that students are looking for. Now, I also always offer creative, optimistic closings. And with any of our learning activities, whether we're using a protocol, whether we're using a Jamboard, it's important that we celebrate the learning, yet we add closure and calmness before we move on to another activity. One of my Jamboard activities that I have here now that you can click on that link, and that will force you to actually make a copy of this particular one. But what I like about this is called Triangle, Square, Circle, and it's an exit ticket reflection. This is designed within a Jamboard. So when you make your copy, you can go up and make a copy, and then you can name it, and it will give you 20 boards or frames, you can say, that you'll have for each of your students. What I normally do, if I have younger kiddos that are working with this, I may preload their name already. If I'm working with upper elementary and middle or high school students, they know already the process that they claim their slide, they put their name in the upper right corner and they name it. And then what they do in the first square rectangular box on the left side, they're going to drag their response to their area of how they felt that they successfully or unsuccessfully completed their particular learning at that station. Then the triangle points is that they're going to reflect on what are 3 critical points that connected the learning for you and supported their triangle thinking from start to finish. And then what they'll also do for me is that they're going to square those ideas away. And when they square those ideas away, what ideas from today are squared away in your thinking to build knowledge and new learning confidence? So that's going to give me just a brief summary. Then in our other part that we will have is their circle thoughts. What thoughts or questions are still circling in your head? And that's one thing that we've realized with students. We don't give them enough time to think about the questions they have and to purposely respond to ask the questions that they need. So this is a great way to have kids collate their questions that they have. And it's a great way for us as teachers to do that just in time check in with them and to give them that personalized and immediate feedback as well. The supportive resources for everything that we have here today that I'd like to share with you include all of the linked resources and more. So a lot that we have for CS for All Teachers, we've done some pre-recorded and some live webinars. So I've included some of those as our back to school CS mixers. I have some other types of learning activities that will extend the coding quest as Dash and Dot Fairy Tale Adventures. I have some more ways to engage girls in computer science, some great NGSS, which is everything for engineering and science for our student activities. I always want to give a shout out to the San Francisco Unified Computer Science Group because they've done such a nice job with a scope and sequence and a framework to help with implementation of these types of activities. And then also we have another archived webinar there for you. It's called CS Coding Activities to kick off the hour of code that you can use all year long. The LinkedIn presentation today is also included for our coding quest as well. If you're looking for more ideas, I have just a plethora of things to share with you. So I wanted to make sure that you have the EduProtocols that I've included here and also the printables that we had shared earlier on. So thank you so much, teacher friends, for joining on this multimedia presentation today. I hope that you've gleaned a whole lot of ideas, so much so that you're going to be busy creating and making over the summer or into the fall year, that you will have so many different ideas that are going to complement what you already do in your classroom. Please remember to visit us back at csforallteachers.org. Please join our community of learners that if you like what you saw today in this multimedia presentation, you're going to love what the online virtual learning community has for you. We have all kinds of resources that support what I've just shared today, but wonderful teacher ambassador friends that can help be wonderful mentors and coaches to all of you as teachers to be more successful with implementing coding and coding quest activities in your classroom experiences. Once again, I want to share and say thank you so much for CS for All Teachers. Please feel free to sign up for our online learning community, and we'd love to learn with you. Thank you once again for the National Science Foundation has provided a grant to make this all purposeful, and we're very thankful that we can provide for you this wonderful professional development opportunity.